Having slaked some quicklime, and then we slake it to a putty as I've demonstrated, we're now going to do a hot mix. Now a hot mix is where you take your quicklime and your aggregate and you mix them together. So instead of slaking the lime on its own, it gets slaked within some wet sand basically. There are certain properties that apparently are beneficial for this, and one is that the lime, as it slakes, as it expands and as it gets hot, binds with the aggregate slightly better than if you do it cold afterwards. So what we're going to do is we're going to mix a ratio of quicklime, powdered quicklime, with some quite well graded aggregate. Now the ratios, if we were using a putty or a natural hydraulic lime, we might be using a 2.5 to 1. Because this quicklime doubles in volume, we're more likely to use a 5 to 1, which actually ends up as the same proportion. And we have to be careful with adding any water. If you don't add enough water, you can get an overburnt reaction. It gets too hot. If you add too much water too early on, instead of slaking, it drowns the lime. So there is a little bit of care. It's not rocket science. It's just being aware that you can cause slight problems if you do either of those. Now I've already mentioned that the quicklime comes in 3 forms. We tend not to use the lump lime. If we were doing an experiment or a demonstration where we were actually burning some lime, we might do that. But in the bought bagged quicklime, as a powder, the moisture gets around the surface of those little grains more easily than the kibble and the little pellets. The risk is that if you don't get all your lime slaked early on, if you were to apply that lime as a plaster, any unslaked lime, when it comes in contact with moisture, will slake and it will expand. And you quite often see in historic buildings certain parts of walls where it's popped. And that can be where the quicklime's come in contact with some moisture, possibly just through dampness or through humidity, and it then expands and cracks or pops the lime. If you're a mason and we were building stone walls, that actually might be a benefit. Because what it might do is once we've actually laid our stonework or our brickwork, if any water was to come in contact with unslaked quicklime and then it reacts, it will expand, and that can counteract shrinkage. Not all masons have that view, but quite a lot prefer to use the kibble for exactly that reason. So what I'm going to do now is I'm actually going to do a little hot mix to see how it works and those little rules that we've got to do to keep it warm, to not flood it, to not drown it, and then to actually make a mortar. Always, as before, when it's in a powder form, we'll have a mask on, P3 mask, and always the safety glasses or goggles. You will note that the trug I'm using it's flexible. It's not plastic. Again, this is from recycled tyres, and it's a pretty obvious reason why we can't use a normal plastic bucket. It would melt. And that is not a good thing, to have your mortar just melting through a bucket. So, as I said, some quite well graded aggregate. 5 of those. This has been stored under cover and has got quite dry. To use the construction term, it is now thirsty. But we also want it damp to help with the reaction with the quicklime. So I'm just going to give it a little dampen. You can see it changing colour as again it gets wet. We don't want it flooded, we don't want it soaked, we just want it damp. And you will notice again it's bulking. Do it a bit more. If this was aggregate that had been stored outside or delivered, chances are it might be damp already. So we create our volcano. And we add our powdered quicklime, 1 to 5. And this is going to start slaking instantly. You can see it already starting to bubble and steam. Just going to give that a little bit more water, it just looked a little bit dry. And you can see it expanding. That's the heat inside driving off excess water and making the cracks because the lime is expanding. Now all of the recipes, all the old recipes, will tell you that this is where you should keep that closed in. You should keep that steam within the mix and close in those cracks as they occur. So what's happening is the lime is expanding, it's generating heat within the slake and it's binding with the aggregate. And you can see some steam coming off. We've got 98.5. It's obviously hotter than that in some instances. 99. (102). What that's just showing you is that the heat in there is not excessive. If we start going into 200, which this might do, as we leave this here slaking, it is going to get hotter. We'll leave this for 15 minutes, 10 to 15 minutes, just so that the slaking takes place. If we flood this and disturb this too early, we can interrupt that slake. And what will happen then is we will kill the actual production of the lime which we need as our binder. So we need to leave it to do a little bit of work. Low 90s, high 90s. You can see it's still steaming. But I think that's done quite a little bit of slaking. So now we need to get it mixed up. And there is still a powder in there. Could possibly have added a little bit more water early on. Still warm, it's still slaking. Just like with the putty mixing, you will notice now it's slaked. You can get it more plastic by, you see the water coming up. Now we have a hot mixed lime mortar. And it is. That is as warm as a hand warmer, those gel hand warmers you can buy. But as a building mortar, that is ideal. We can, just like with the putty mix, we can leave this to mature. We could leave this, as long as it's kept away from air and doesn't dry out, indefinitely. But as a hot mix, there are those two separate issues. We've mixed it, we've slaked it hot, and then we can use it cold or use it as a hot mix. So there's a hot mixed mortar used hot and a hot mixed mortar allowed to cool down and use as a more mature pure lime mortar. We've left this hot mix for 10 or 15 minutes and you can actually see how it's stiffened up, and that's due to the water evaporating. So it's now got we keep it flexible, we keep it workable, and we can revitalise it as much as we like. So if we are looking for the most permeable, the most breathable type of mortar, this would be it. Or the one mixed with a putty, a mature putty that I did earlier. This is probably one of the best mortars for most historic buildings. If we wanted to make this mortar more durable, we would add a pozzolan. And we would add a pozzolan at the end of that slaking process. Before it's fully slaked, but not at the beginning. I find that doing it right at the beginning does have a slightly speeding up the actual initial set too much, and this would now be quite hard too early, which might be an advantage in some instances. But a proportion of pozzolan, maybe 10-15% added just as we were making this workable, would make this have a slightly faster set, initial set, a hydraulic set, and would make it more durable. But it is still a very good mortar. But this is the ideal.